All right, guys, welcome back. So next up for our trigonometry with triangles is the law of cosines. So we've discussed right triangle trig, we've discussed law of sines and how that related to the different sides of a triangle. We also have law of cosines. So it's the same two formulas, really the same based on this formula right here. That's what everything is based on, just switching the variables around and then solving for the angles as well. But this is the relationship between the three sides and the angle based on law of cosines. A side squared equals the other two sides squared, subtract by the 2 times those two side values, and cosine of the angle across from that side. So that's always this format. If I want to solve for the angles instead, that's where I'm doing cosine A, cosine B, cosine C by itself with those two fractions. Now for the law of cosines, you're going to have two cases, which again you should recognize from geometric proofs in geometry, side, 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 and side, angle, side. Those are the ones you're going to use law of cosines for. Because if I have side, 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 I have no angles, I cannot possibly use the law of sines. And even if I'm given an angle, if it's in between the two sides, I have no opposite pairs of side and angles to be able to set up my ratios for. So that's where the law of cosines comes into play. Now with side, 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 you're going to always want to solve for the biggest angle first. The reason why I recommend that is because after you get the first angle, you could then use law of sines or continue to use law of cosines to solve for the remaining two angles. And if you choose law of sines, you're going to always want to make sure the biggest angle is solved for first. That way you don't have to worry about not having the obtuse angle done correctly, like the law of sines can't tell you the obtuse angle. Also, because you're going to have to then use ratios, you're going to have to use the side or angle you're solving for, make sure you're always storing the information as a variable correctly. But if you stick with law of cosines the whole way, you're not going to have to worry about that. What you do need to worry about for side, 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 though, is this special case, because you need to verify you first have a valid triangle. The two smallest sides have to always add to be larger than the third side. If that's not the case, you don't actually have a triangle, and your answer is no solution. And if it is the case, then you can solve it out because you do have a valid triangle. So like here, I'm going to compare my two smallest sides, 8 and 17, and I'm going to compare that to my 21. I get 25, which is greater than 21, so I do have a valid triangle. So the way I'm going to solve this out, I'm going to solve for the biggest angle first, which is obviously the angle B. It's across from 21. So cosine of B would equal, the way it's going to work is it's the two other sides squared added together. So 8 squared plus 17 squared. And I'm going to subtract by the side that's across from the angle, so 21 squared. And on the bottom, it's 2 times 8 times 17. Now, the way I would recommend doing that is you're going to figure out the entire top first. So 8 squared plus 17 squared minus 21 squared. That gives you a negative 88. And then 2 times 8 times 17, that gives you a 272. You're just going to do the cosine inverse of that fraction. Negative 88 divided by 272, sorry. And we get angle B to equal 108.877 degrees. That way you can't make a mistake in terms of the mistyping of anything with this. If you want to try and do it all in one step, I would really recommend using your alpha y equals button to create the fraction, or you got to be very careful with your parentheses. Now, once we have one angle, we certainly could go to using law of sines, and some students prefer that to be able to solve out the rest of the problems because law of sines is a bit more straightforward in application. Personally, for me, if I'm given all three sides, I'm using law of cosines the whole way, because cosine of angle A would just simply be 21 squared plus 17 squared minus 8 squared over 2 times 21 times 17. So the top part, 21 squared, 17 squared minus 8 squared is positive 666. That was not an intentional demonic number right there. And then over 714. So A is going to be a cosine inverse of 666 over 714, which is going to give us angle A to be 21.129 degrees. Now, once I have two angles and I'm using them anyway to kind of solve out, I'm just going to go ahead and say angle C is 180 minus A minus B. So 180 minus the 108.877 minus the 877 there, minus the 21.129, we get 49.994. Perfectly fine right there. If you want to use law of cosine to solve it out instead of doing that subtraction stuff, that's also fine. Kind of your choice there once you get to the first two angles. And again, if you want to use law of sines, you could have also done that to solve for angle A and angle C, but just make sure angle B is stored as a proper variable. With subtraction, it's not going to make that much of a difference when you're subtracting with rounding, but if you're trying to like do cosine inverse, sine inverse, or multiply and stuff like that with a rounded off answer, you could get a little messed up. Now this is the example right here where if we're not checking, you're going to kind of think, oh, I can solve this out. When in reality, you really can't, because this is not a triangle. 32 is bigger than the sum, which is not good, so this is no solution. There's not a triangle here. So you always want to make sure you're comparing the sum of the two smaller sides to the third side and make sure you have a valid triangle scenario. Assuming you do, you honestly use law of cosine to solve for all three angles. It's very straightforward. Now, for side angle side, you need to solve for the missing third side first, because then that's where you're using the side squared equals the other two sides squared and all that. And then the two remaining angles can be law of cosines again or law of sines. Regardless, you are going to have to store that third side, so no matter which one you go with, you need to make sure it's stored exactly because you're going to use it for law of cosines or you're going to use it in law of sines. And also watch out. If you find out that your given angle is not actually the biggest angle, then you need to make sure you do not use law of sines to solve for the biggest angle then. You'd want to solve for the other angle and then just subtract from 180. Or again, you can stick with law of cosines. And I'll show both options really. So here, we're obviously given angle A, side B, and side C, so we have to solve for side A. So A squared would be B squared plus C squared minus 2 times B times C times cosine of A. And we're just going to do the square root of that whole thing all in one big step. So we're going to get A to be 28.379, and we're going to make sure we store that because we need to use it no matter what's happening here. So that's stored as alpha A. Now, if you want to solve for angle B and angle C using your law of sines, well, angle A is the biggest angle. We know that because, well, it's bigger than a right angle to begin with. Also, side A is the biggest side anyway, so it's a guarantee there. So we don't have to worry about using law of sines to solve out for anything else. So we can go ahead and just simply say with that route, sine of A, so sine 91 over A equals sine of B over 25. Again, using A as the stored value there. So we get 25 sine 91 equals A sine B. We divide over the A, and then we do the sine inverse of this ratio. So you'd be doing sine inverse 25 sine 91, closing the parentheses, divided by alpha A for the side there, and you get angle B, if we go this route, to be a 61.740 degrees. And then I would just simply go, okay, so I've got angle B and angle A. Angle C would just be 180 minus 91 minus 61.740. And angle C would then be 27.260 degrees. So that's your option if you want to use law of sines to get to your second angle and then do your triangle sum to solve for the third angle. That's not a bad option for this. And again, I know we had talked about with the right triangle trig avoiding using calculated values to solve out the problem there, but again, there wasn't a choice. I have to use side A to solve for the next angle anyway, so I might as well just trust that I did everything correctly and just kind of work through it that way. So that's using law of sines. We're going to do one more, and I'm going to use law of cosine to solve for what's missing for this one. So here we're going to solve for side B. So it'd be B squared equals A squared plus C squared minus 2 times A times C times the cosine of angle B. And we're going to do the big square root of that whole thing all in one step. So B is going to give us, turns out to be 18. It's not exactly 18. I do want to point that out. When you do this in your calculator, so let me type it out, 17 squared, 30 squared minus 2 times 17 times 30 times the cosine of your 32. I'm getting 17.999748838, which is rounding to 18 for the thousandths place. So definitely make sure we're not using just 18, we're storing it, and I'll store it as alpha B. Now, clearly for this question, angle C is going to be the biggest angle because C is the biggest side. So if I want to use law of sines, I would not use law of sines to get angle C because it's guaranteed to be wrong. So what I can do instead is I can use law of cosines to get angle C instead. So I can say cosine of C would equal 17 squared plus b squared minus 30 squared over 2 times 17 times b. Now in this case, we kind of have to do the cosine inverse of that fraction all together. So that's where, again, you're using your alpha y equals to type in the fraction button, or you're putting parentheses around the entire numerator and entire denominator. So for the fraction button, it would just kind of look like that right there. Fraction, 17 squared, b squared, all that kind of stuff. You're going to get 117.968 degrees. If you want to type out with parentheses, you would say cosine inverse. It would give you parentheses. You would create your own. 17 squared plus b squared minus 30 squared. Close it, divided by, create a new one. 2 times 17 times b. Close it, and then close it. Then once we have c, again, angle A could just be 180 minus 32 minus the 117.968. And angle A is 30.032 degrees. So that's how the law of cosines work for that. And because of the whole storing of the variable, writing it twice, and being a little obnoxious for the cosine inverse part is why a lot of students prefer to work with law of sines instead. And that's perfectly fine. Just make sure if you want to use law of sines for this problem, you'd use law of sines to get angle A and then subtract A and B from 180 to get angle C. Okay, so that would be my recommendation if you want to use law of sines. But I wanted to just simply show you what law of cosines would look for the second part there. All right, so right triangle trig, law of sines, law of cosines, those are all your options to solve for missing sides and missing angles of a triangle. The nice thing is the right triangle trig stuff, you don't need to use that. You could just do law of sines and law of cosines instead for those problems once you recognize whether or not it's, angle, side, angle, side angle, side, all that kind of stuff. All right, so that's it for the different trig methods. We're going to talk about how to use this stuff to find area of triangles, as well as work with different word problems that we have to set up our own triangles and figure out which method to use. So I'll see you all next time for that.